Guys, so we're in that middle section, friction problems. We're looking at number 1 together. And I'm going to have to ask for a little help because you guys have the copies and I don't. Some of our problem solving hasn't changed. First, I'm going to find the givens. Because I happen to know in this question we've got a box that we're trying to push along the floor, and it gave us a couple of things. Who can see one thing we're given?
The brick is 2 kilograms.
What is 2 kilograms?
Weight.
No. Try again.
Mass.
Yes. All right.
But who else said that so
Now, and guys, I said that like that, and please understand there's a big difference between mass and weight. That's okay. That's okay. But seriously, it's not an uncommon issue. It's not an uncommon mistake. Mass is in kilograms. Weight is one of our forces. So weight's going to be in newtons. We're going to come back around to weight in just a minute. But please know, when you see kilograms, that's going to be mass. And then there's a second thing given.
The force of friction is 8 newtons.
Force of friction is 8 newtons. Now I'm going to be color coding this as we go, guys. So every time force of friction comes up, you're going to see orange. And all the other forces we talk about, they're going to have their own unique color. All right, as you finish reading question 1 and the friction problems, you see that is all the given data. That's it. And there's a question. Oh, we should write down the question, right? What is the
Coefficient of friction.
coefficient of friction? That's that mu guy. I'm like, okay, coefficient of friction. I've seen that somewhere. Have you guys seen an equation with mu in it? You can check your notes if you need to. We ended with it Friday. We kind of started with it on the slide today.
F equals, said mu.
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 Like a kitten. Mu.
F. Wait.
Yeah.
Yeah.
Yeah. All right, so normal force. There's another force. I got another color for you. Okay. Well, hey, I know the force of friction. That's given. But I don't know the normal force. So this is that moment. We either give up and go home. Don't recommend that choice. Or I go with why we're doing this right now. Let's draw the free body diagram. Because from the free body diagram, I can probably get some help.
Oh, yeah.
Oh, okay. Danny, what do you want? A box or a dot?
A box.
A box. I mean, the question said it was a box. I think that's a good choice. Okay, so I've got a box. Can one person tell me one force acting on this object?
Friction.
Friction. I know friction's acting. If friction's acting, that should tell me something else is going on. But I like to, and again, it's not wrong, I know friction's going to be parallel to the surface. I usually put it over here on the right, acting against the box. Because what that tells me is there's another force acting that either it's stated or it alludes to. I must be doing what to the box?
Pushing.
I must be pushing the box. So I've got that applied force happening to the box as well. That's me pushing, and friction saying, not happening. All right, can I get a third person to tell me another force that's probably acting on this box? Weight, there you go. And which way is weight?
Down.
Straight down, straight down. All right. I know that sounds really funny to say, but I say it because by the end of next week, we're going to put you on an incline. And there's down the incline, and there's straight down. And weight is always straight down. That's why I emphasize it so much. All right, if there's weight straight down, I'm either falling or I'm on a surface. Since there's friction, I must be on a surface. What's the last missing force? The normal force. There you go. All right. And basically what I just told you guys, as soon as you've drawn a free body diagram, you can then write at least one and possibly two equations to help you out. They're based from Newton's second law. M times A. I'm going to write 1 in the x direction in my horizontal. And I'm going to write 1 in my y direction in my vertical. Equals. You got a strong preference for which one we do first?
The top one.
The top. Well, yeah, why not? You wrote them in some kind of order. Horizontal, that's left and right. I see an applied force. So I'm going to write F applied. And I see a friction force. Are those arrows going in the same direction or in opposite directions? Opposite, so I'm going to put a minus sign in the middle. There you go. There's one net force equation. Hopefully with that, you guys could probably jump ahead on the second one. Why don't you try it? You've got pencils. I've got dry erase, so we can edit if we need to. I'm going to try it too. Check your work. I had two forces going up and down, and I noticed the arrows were in opposite directions. Question?
Does it matter if it's like FW minus FN?
Yes and no. You have to be careful. Which way are you going to call positive and which way are you going to call negative? Okay? I've decided that up is going to be positive and down is going to be negative. So I've got the negative with the arrow that's pointing down. So that when I have a situation where there's acceleration, we have to have that acceleration match as well. So if it's accelerating upward, I want it to be positive like the upward force. If it's accelerating downward, I want it to be negative like the negative force. So signs are important, and we're going back to that XY idea, positive Y versus negative Y. I think I have my arms backwards. Positive X versus negative X. There we go. So the question was, way back over here, things like we took a side trip. We knew the force of friction, that was given. We want mu. Is it possible to get the normal force with that net force equation? Yes. Yes, I'm going to have to do a little thinking though. I was given the mass. 2 kilograms. Is this brick or box on the tabletop or on the floor that we're pushing, is it accelerating up and down?
No.
It is not. Its motion is not changing. So that's a 0 right there. See, I'm looking for my normal force. Do I know, and I told you we'd come back to it, do I know the weight? I know how to get the weight, right? We were given mass. And I remember that weight is actually mass times g. And for Earth, that's 9.8 meters per second squared. Is that okay that I wrote it like that? I took FW, I'll write it to the side, just in case you're reviewing later, equals m times g. And instead of doing it to the side, I literally just plugged in m times g. There are some people in here who remember from projectiles 2 times 9.8. We used it a lot. Not quite as much as half 9.8, but we used that a bit too. 19.6. Now, new question. Does anybody remember what a kilogram times a meter per second squared is? Uh-oh. Well, what was this number representing? Force of weight. What do we measure forces
newtons.
in? There you go, newtons. Newtons, yeah. I'm sorry, big stretch on the day, right? How about 2 times 0?
0.
Is there anybody who knows what a kilogram times a meter per second squared is now?
A Newton.
Newton, yay, 0 newtons, not on, but 0 newtons. We get 0 joules and everyone thinks it was OJ. All right, now I am finally ready to get the normal force. How do I do subtraction? I add 19.6 here. I have to do it over here. So I find out the normal force is 19.6 newtons. I can finally answer the question, guys. How do you feel like we answered 15 questions already? Yeah, maybe not quite, a lot. That was a lot of work to get one answer. There's a reason there's only 5 practice questions right there, okay? Let's answer the question. Force of friction, 8 newtons, was equal to mu times the normal force. Well, I undid subtraction with addition. How am I going to undo multiplication? Division. 19.6 goes away over here. 19.6. And somebody with a calculator, because that is definitely not going to be my mental math cup of tea. What did you get? 0.41. And I have one last question. Does anyone know what a Newton divided by a Newton is? Over here they canceled out, so guess what they do over here? They cancel out. My answer, the mu value, is a unitless number. It's the one time you forget to write units, and it's okay because it doesn't have any units. So let me recap. I know that looks like a lot. It actually gets faster and faster the more you practice. This is one of those things that's really good to practice because it does get faster and faster. We got our givens pulled out. You could have started or ended here, or you could have come over here first. We stated the equation we knew we needed because it's the only place mu shows up. We drew our free body diagrams, wrote net force equations. Turned out we didn't need this one this time, but it was good practice to write for both directions. Found the normal force, which was missing, in order to come back here and solve. You've got 4 more down there. They're not all the same. They don't all happen the same way, but you need to practice at least 2, if not all 4, because the more you do these, the faster they get.